we've got a 45 kilogram crate placed on an incline ramp. When the angle of the ramp is horizontal is 23 degrees, the crate begins to slide downward. What is the coefficient of static friction between the crate and the ramp? So first we need to do what? What's the first step in solving a force question? Draw a free body diagram. Now this crate is on an inclined plane, so let's make the x-axis ... and a y-axis ... so that we have this is along the x, the plane, the inclined plane, and that is perpendicular to the inclined plane. And then I'll make my object just a little dot that can represent the box. So what is interacting with the box sitting on this inclined plane that's just about to slide? Any ideas? The gravitational force, absolutely. And it is pointing straight down. I'm going to go ahead and label it FG. Is there anything else that's sitting on an inclined plane and it's not sliding? Friction. Which way would the friction force be acting on this guy? Up the inclined plane because it's holding it from sliding down. And that would officially be static. So if you want to throw a little S there for static, that's good. Now what about, is there anything else it's interacting with? The normal force, the actual plane is holding it up. It's not falling through the wood or anything like that. So that's your normal force. Now based on our discussion earlier, what is the angle right here that the weight force makes with the new y-axis? Theta that was given in the problem, and I'm just going to write it as theta. So now I have all my forces drawn and labeled. Next step is to sum the forces. So now we have forces in the x direction, and we have forces in the y direction. And this guy is not going to slide, so it's still in equilibrium. So the net acceleration in both dimensions is 0. So go around the circle, or go around the coordinate system, go around whatever you want to call it. Is the normal force in the x direction, y direction, or both? The y. So it is not a part of the forces in the x direction. Next, friction force, x direction, y direction, or both? It's only in the x direction. Is it pointing positive or is it pointing negative? Positive. So we have a positive force of static friction, like that. Now go on around. Weight. Is weight pointing in the x direction, the y direction, or both? It's both. So we need to add its or include its x component. So if you look at your notes, the x component of the force, because it's opposite of the angle, okay, would be our FG sine theta. Now, would it be positive or negative? Is it pointing up and positive or down and negative? It's going down the inclined plane and make that negative. Is there any other force that's in the x direction? No. So the sum of the forces should equal what? 0, because it's in equilibrium. So don't forget to put that equals 0 at the end. So in the y direction, let's go around the circle. Go around the coordinate system. Normal force, x, y, or both? It's in the y direction. Is it pointing in the positive y direction or the negative y direction? Positive. So we've got a force normal that's pointing up in our new coordinate system. Is the friction force x, y, or both? It's just on our x-axis, so it's not in the y direction. Ignore it. Going around. Gravitational force, x, y, or both? Both. Is its component holding the block to the incline or pushing it up off the incline? Holding it to. So is it positive or negative? Down into the, so down, negative FG, and then the component would be cosine theta because it is adjacent to the angle right there. We've taken care of all of our vectors. We sum the forces. It's in equilibrium. What do we set it equal to? 0.